Hey students, it's Mrs. Brunk again, and welcome to lesson 5-4, the side triangle congruence theorem. And this is the fourth lesson of this module. It's actually the last lesson of this module. And this is the fourth shortcut we're going to learn to prove that triangles are congruent. It's not the last one, but it's the last of the ones that can be used for any kind of triangle. And this one's called the side. So recall, now this is our kind of running list now. We started off, we learned the angle, side angle. And we learned the side angle, side. Now, along with the side, and these other two we have learned in prior lessons, that brings us up to 3 shortcuts. And then remember, the first way we learned was to show that all 6 parts of the 2 triangles were congruent. But we decided that's way too much work, and if we can do it with less, we're going to. And so far these are the 3 ways, well, the 2 ways, and then the new one today, side. So our learning goal is we're going to be able to prove 2 triangles are congruent using the side theorem. So just like it sounds, I mean, it's not going to involve angles at all. We just have to, like in that first lesson when we went through and we showed that all like 3 pairs of sides were congruent, and then we proved all 3 pairs of angles were congruent, we could have actually stopped with the sides. We didn't really have to show that all 3 angles were congruent. And so sometimes when we learn the side, then students will ask this question, well, is there an angle theorem? And the answer is no. Just knowing the angle measures, I mean, the angles in a triangle always add up to 180. So, you know, that relationship with just, if you had all angles in a triangle, that the 3 pair that were matching up, well, you could make the sides be much longer in between on the one triangle than the other, and that's not changing the angle measures themselves. So those triangles wouldn't be congruent. They'd actually be called similar, and we'll learn more about that as well later in the course. But to make them congruent, you'd have to have more than that. You'd have to know at least one pair of sides in the 2 triangles were congruent. It's not enough to just know angles. But it is enough to know just all 3 sides. And you think about if you had set lengths for all the sides of a triangle to be, there would be no way to put them together but just the one way, because the sides all have to meet at the ends, at the endpoints, right? If you can kind of imagine, we used to always like to do this activity in class where we would just take all these straws of certain lengths, okay, and we'd make so that everybody had sets of that 3 straw lengths that were all they were the same as their neighbors or whoever. And when we lined them up to make a little triangle out of them, of course they were going to be the exact same size triangle. So, and that's because the sides are rigid. They're set at certain lengths, and there's no other way to connect them then. So how that would look on the drawing as we mark things, we'd say, like, let's say these 2 were congruent. If we said these 2 were congruent, and then of course the third ones. So would be all sides marked congruent and side. No angles necessary. So we're going to be doing some of the same things we've done in the other lessons, where we're either verifying with the information that's given, or showing that maybe there's information that shows that the triangles aren't congruent in fact. So looking at this first example, let's see, I see a side that's 1.7, and here's one here. There's a side that's 2.3, and there's one over here that matches, and then there's a third side that's 2.4, and this one's 2.4 as well. So these triangles are congruent, and if we want to write a congruent statement, we could say we called this triangle at the top A, B, C, so we went along the 1.7 side onto the 2.4, so that would go D, E, F for the other one. So we'd say that's congruent to triangle D, E, F. And then that's by the side theorem. So taking a look at this next one, okay, first of all, I see a side that is 54 in this triangle and one that matches here. I see one that's 38 and one that's 38 here. But then you can see this third side is 28 inches in the left-hand triangle, and the right-hand triangle is 32. So these are not congruent, right? These triangles are not congruent. So again, we can use the theorems in the reverse to show if, in fact, you don't have three pairs of equal sides, and you haven't met any of the other shortcuts we know either, then if you could find something like, say, okay, these two sides are actually not the same length, and they would have to be the corresponding sides, then it's enough to show the triangles, in fact, are not congruent. Okay, let's look at another example here. Okay, so we've got, let's see, two sides that are 12, so mark those congruent. We have two sides that are 20, and we have two sides that are 24. So those are congruent. So I could say triangle, let's call, say this bottom one D, E, F. So notice I started at D and went along the side that's 20, so I'd start at H and go along the side that's 20 here, so that would be H, G, no, I'm sorry, that's not H, that is, so I think I labeled that first triangle wrong. They had H, I think, is right there at the center, so that was D, E, H, and then we'd have to go with, let's see, that's an F that's over here. F, G, H. So those are congruent, and I forgot to put a spot for the triangle in there. There we go. And the reason is the side, side, side theorem. So what about D? So this time I don't see any measurements listed on them, but I do see some markings. I see these two are marked congruent. I see these two are marked congruent. Okay, and that third side for both those triangles is the shared side. So, we've got that reflexive property that says that if that something is always congruent to itself. So we really do have enough to say they're congruent by side, side, side. So let's say I called the one triangle on the left, say GKJ, then the other triangle, I would have to name it as GLJ. And so they're congruent by side, side, side. Now, following the same pattern of all the other lessons, one of our learning goals is to see if, well, can we tell what more information we would need? Now, we might not have a way to tell that right now with the given information, but what more would we need if we wanted to use side, side, side here? So you can tell that in this, in A, we know that these are congruent. We actually already know that another pair of sides is congruent. So what we actually really, so we already have that, essentially, we have that. We don't need it, it's already there. We can tell right away that they have that shared part. So the part we really do need, we'd need more information for, is to show that SR, we would need SR to be congruent to IR. So if we knew some actual measurements for those that showed they were the same, then we would know that the triangles were congruent. And similarly with B, I mean, they do have a shared part, so that's kind of a give me. It's like a, an automatic. We know for sure that that's a second pair of sides congruent. So what we'd need to know is that we'd need to know that, and again, need to know that VL was congruent to MN. And then that would be enough to go side, side, side. And by the way, I'm really sorry about how noisy my dog is. You can, I'm sure, hear her snoring. Well, you're probably used to this by now. She snores through every video, but once I sit down to make a video, she's going to be right by me, and it takes her about 2 minutes to fall asleep and start snoring. So just try to kind of ignore that background noise. And hopefully it doesn't make you too tired. So our final example today is going to be a nice short lesson today. So this time we want to use algebra and what we know about what would be true if these triangles were in fact congruent to find some values of some unknown variables. So in example A, I can tell by looking at the markings that, well, first of all, we have a couple of isosceles triangles here, and we've got two sides equal, right? So really, I could mark these both as the same and these the same. So even though they're all marked the same, I still have two pairs of sides being congruent. So if these triangles were congruent, then I would know this third pair of sides would have to be equal. And so if I wanted to find out what x is, I could just say that 4x minus 6, which is this side right here, would have to be the same as this side right here, which is 3x minus 4. And then I just have to use some of my equation solving skills. So say maybe I want to bring this 3x to the other side to be with the x on the left. I'm going to subtract 3x. And that leaves me with x minus 6 on this side. And on this side I have negative 4. So my next step would be to move this minus 6 over to be with the minus 4 by adding it. And that leaves me with x on the left and 2 on the right. So if x were 2 and I were to substitute it back into these expressions, it would make this side right here 4 times 2, which is 8, minus 6, which is 2, and substitute it in down here, it would be 3 times 2, which is 6, minus 4, which is 2 as well. So then we'd be able to see they were both the same length there. Okay, let's look at B. So similarly with B, we've got sides that are the same, two pair of sides that are actually the same length even. And actually these triangles are equilateral triangles, because I can see that this one's also marked 4 inches. So for these to be congruent, then this right here would also have to be equal to 4 inches. So that's what I could say to find x, is that 3x minus 11 is equal to 4. So a couple quick steps to solve. I'm going to add 11 to both sides. That gives me 3x. Oops. 3x is equal to, oops, that's supposed to be an 11 over there. Yikes, that's an 11. So that would make that into 15. And that means if I divide by 3, x must be 5. So substituting 5 back in, 3 times 5 is 15 minus 11, that would make that missing side 4. So we know that's correct. We know that x must be 5. So now this final one, notice the triangles have x's and y's in them. So if these triangles are in fact congruent, right, we know that all the matching parts have to be the same. And so we know that this side right here, that's listed as 12 centimeters, would have to be the same as this side over here, that's listed as 8x minus 12. So first thing I would do to find x is to say 8x minus 12, equals 12. And that's to find x. Now to find y, I'm going to look at another pair of parts. So let's see, y I see appears in this angle right here. Now that angle right there has to go with this angle over here. And that means that 7y plus 4 must equal 60 degrees. So at this point, I'm going to make this a you-try question for you to complete the solving of these by yourself. So pause the video now and solve the two equations for x and for y. And then you can tune back in and we'll check our answers. So pause the video now. Alright, so thanks for giving that a try. Our values for x are 3 and y 8. And if we've substituted 3 back in to that missing side, that would be 8 times 3, which is 24, minus 12, which is 12. And again, that would make the two sides, HG and VU, be the same. And then same with the angles. If you substituted 8 back into angle T, that would make that angle 7 times 8, which is 56, plus 4, which is 60. So then you could see that those angles are congruent. So that actually does it for today's lesson. And like I said, this is the third of the shortcuts. There are more to go. But as of now, we can prove triangles congruent with either showing all 6 parts or showing that we have 3 parts, but 3 specific parts. They have to be an angle, a side, and an angle. So in other words, 2 angles and the included side. the side angle side, which is 2 sides and the included angle or the angle that they make, and then all 3 sides for side, side, side. So that does it for today. Thanks for coming to class.